DrACO, the drill for acquisition of complex organics, is the sampling system for Dragonfly, a mission to send a flying spacecraft to search for signs of life on Titan. Titan is the only ocean world in our solar system with a dense atmosphere, and the unique organic chemistry that takes place on the water ice surface makes it an ideal location for such a search. To study Titan's composition, Dragonfly carries onboard science instruments that analyze ground material from numerous landing sites across Titan's surface. DrACO is a robotic system on Dragonfly that acquires samples of surface material and delivers them to the science instruments for analysis. DrACO is comprised of 4 unique subsystems. Redundant sample acquisition drills extract material from the ground. The pneumatic transport system moves that material inside the vehicle. The sample delivery carousel presents that sample to the instruments, and avionics orchestrate and automate the process. Honeybee Robotics has developed a full brassboard end-to-end sampling testbed to demonstrate DrACO's performance. Sampling is a 6-step process whereby ground material is excavated, transported inside the vehicle, and ultimately delivered to the science instruments. As a first step, DrACO can take preliminary measurements of the surface by drilling a shallow hole. Drilling data and close-up images of the cuttings help inform the decision of whether to continue sampling at that location. Next, DrACO is configured using pneumatic valves to select which drilling site to investigate, which blower to vacuum up the cuttings with, and which instrument to use for scientific analysis. The carousel then moves one of 58 single-use sample cups into the collection chamber, and the system is ready to acquire a sample. Before drilling, the selected blower spins up to cool down the pneumatic tubes with cold Titan air. As the rotary percussive drill bores into the surface, the cuttings are sucked up and rapidly transported through the tubes, just like in a household vacuum cleaner. The vacuumed up cuttings fly through the system in a fraction of a second. As the sample passes through the collection chamber, a mesh plate deflects the particles into the sample cup, where they are trapped. Excess sample simply passes by to be ejected outside the vehicle by the blower's exhaust. Phase A testing in a near-Titan environment has demonstrated this collection method to be gravity agnostic and robust to cohesive simulants. After the cup is full, the drill retracts out of the borehole while percussing and spinning to remove any built-up material from the drill bit and pneumatic inlet. The blower then flushes out residual material from the tubes and is spun down to a stop. To complete the process, the filled sample cup is removed from the collection chamber and positioned at the corresponding instrument chamber. 4 elevator mechanisms in the warm zone underneath the carousel lift and lower sample cups. The sample cup hermetically seals to the instrument through a knife-edge interface. DrACO can deliver sample to either of the 2 instrument modes that Dragonfly is equipped with to analyze material taken from the surface. In gas chromatograph mode, the sample is heated to release volatiles that flow into the mass spectrometer, where their composition is determined. In laser desorption mode, a laser ionizes the sample through a thin mesh window, and the liberated ions are ingested into the instrument. The cup can be repositioned to take measurements at multiple locations for improved accuracy. We don't know how life came to form on Earth, but the science that Dragonfly will do on Titan could provide a key piece of that puzzle. DrACO has been engineered to empower the Dragonfly mission in its search for life, answers, and understanding.